How do you do again? I am Paul Garber, Historian Emeritus of the National Air and Space Museum, Smithsonian, and Ramsey Research Associate. You will recall that when we were previously together, I told you of the Wright B-1, which was the first Wright-type airplane made for the United States Navy. I showed you this scale model, explained that the airplane itself had been washed out since 1912 when it pranged into Chesapeake Bay, but one significant part of it has been preserved, and that is the engine. I want to show that to you. This is the oldest relic of United States naval aviation. It is a Wright Brothers engine of 1911, about 35 horsepower. It was installed in the Wright B-1, which was a biplane. Had an upper wing and a lower wing, biplane. This is the front end of the engine. This is the rear end. That is, the airplane went that way. And on the front end is this water pump driven by these gears. On this plate was mounted the magneto. Unfortunately, that was not preserved, but we're so glad that the engine itself was preserved by the Navy. The magneto was mounted here, and from the distributor unit of the magneto, wires extended to these 4 spark plugs. The magneto could be rocked mechanically by an arm so as to reduce the speed somewhat, but there was no throttle as such. You took off wide open, you flew wide open, you could slack off a little bit by rocking the magneto for coming in for a landing, but then to stop the engine, there was a compression wire that extended right in front of the pilot and to this lever, so that as this was moved, it would hold up the exhaust valve and thus stop the compression in the engine. On the back end is this flywheel. On this shaft, there was mounted a double sprocket, and from this double sprocket, chains extended to the propellers, the 2-pusher propellers, to the port and starboard sides. Those revolved in opposite directions. We are positive that this is the engine of the B-1. In 1957, I was in San Diego, and there I met Dale Sigler, who told me that he was the Navy's first aviation mechanic. And I told him about this engine. He said if I could see it, I could identify it. So he was brought to Washington, shown the engine. He said, yes, that is the engine of the B-1, because when I was working as a mechanic at the Navy's first air station, which was Greenbury Point, Maryland, across the Severn River from the Naval Academy, I put this patch on the crankcase. And so by his own handiwork, he identified this as the actual engine of 1911. This is the oldest relic of United States naval aviation. On Memorial Day, May 30, 1912, the world was shocked and grieved to learn of the death of Wilbur Wright early that morning. It was known that he had contracted a severe case of typhoid fever, but reports led his friends to believe that he was recovering. But he suffered a relapse and died peacefully at home in Dayton, Ohio. Persons throughout the world who had known this kind, capable, unassuming, quiet gentleman mourned his loss. This photograph was made in France in 1908 when Wilbur was demonstrating the Wright airplane there. And this is a painting made from life in France by the French artist Hervé Mathy. It was given to the National Air and Space Museum by Wilbur's close friend and mine, General Frank P. Lam, and his sister. This is one of the best photographs of Wilbur and is inscribed by him to his friend Léon Boulay, who helped arrange for Wilbur's demonstration flights in France. I sort of like this one best. Wilbur had brought this kite from France to the son of Frank Coffin. Frank was an important member of the Wright exhibition team. It looks as though Wilbur and Frank are having more fun than the boy with the kite. The Wright brothers loved children, but never married. The other 2 Wright brothers, Lauren and Rushlin, did have families. Orville was, of course, the one most saddened by the death of his beloved brother and companion. The marvelous combination of their minds and skills which had brought to the world the first successful powered, controlled, and manned airplane, was severed by Wilbur's death. Orville found some comfort in carrying on the projects upon which Wilbur and he had been engaged. Orville was a superb pilot, and the exhilaration of flying helped to ease his sorrow. This airplane is one of the Wright racing and exhibition types. It was known as the Roadster, sometimes abbreviated as the R. It is interesting, educational, and impressive for us to realize how far the Wright brothers advanced in the design of the airplane. With the exception of the R and the EX and the Baby Grand, they identified their types alphabetically. I'll remind you of the first two, the A, which had the elevator in front, and the B, which had the elevator in the rear. That's the rear view of the B. Now the C was intended for military use and was stronger and therefore somewhat heavier than the B. Its airfoil had less curvature, and it could lift heavier loads and climb faster than previous types. The most visible difference in appearance was the use of vertical vanes in front instead of the triangular form as in the B, EX, and R. The C had a 6-cylinder engine which produced about 50 to 60 horsepower instead of the 35 horsepower in the 4-cylinder engines. It was the C which was used by Lieutenants Arnold, Milling, and their fellow officer pilots at College Park, Maryland in 1912. Here is a float-equipped version of the C, known as the CH, the H designating the hydroaeroplane type. Note the steps in the bottom of the floats. They break open the suction that often prevents seaplanes from getting unstuck from the water. Orville had noticed that in some maneuvers during flights in the CH, the two long parallel floats seemed to interfere with the flow of air to the wing. And after further experimenting, he preferred this single float of rectangular shape, as you're about to see in the next slide. Early in 1912, the Signal Corps requested from the Wright brothers a proposal and bid for a light scout machine. It was to carry one person, have a speed of 65 miles per hour, climb at 1800 feet in 3 minutes, have a 3-hour gasoline capacity, and be easily transportable by road or rail. For this airplane, the Wright's bid of $6,000 was accepted. The airplane, known as the Wright D, was delivered to College Park that summer. That's Tommy Milling at the controls. The first single-propellered airplane produced by the Wrights was Type E. It had a wingspan of 32 feet and weighed 730 pounds without the pilot. Orville enjoyed flying this one. Type F was made for the Army in 1913 and was the first Wright airplane to have an enclosed fuselage. It was powered with a European Austro-Daimler engine of 90 horsepower. Here, a group of soldiers are holding it back while the pilot revs up the engine. In the side view, you can see the Army's number 39 on the rudder. Now, I want to interrupt our alphabetical sequence by inserting an item which will be in chronological order, but in view of the extensive use and importance today of automatic piloting, it is impressive evidence of Orville Wright's foresight and genius. Almost from the very beginning of their experiments, Orville had been interested in developing an apparatus for automatically stabilizing and controlling an airplane. The equipment shown here represents about 8 years of development. These pictures were taken in the winter of 1913. A Type C airplane was used. The group witnessing the flights was a committee assigned by the Aero Club of America to judge the effectiveness of the apparatus. Orville made both straight and circling flights, demonstrating the absolute reliability of the system, and as a final proof that his invention was practical, flew toward the judges with his hands raised high above the control levers. As a final gesture, he tapped the rudder control, whereupon the airplane commenced a wide turn and continued on that course until Orville took over control and brought the airplane into a landing. For the development of this stabilizer, Orville Wright received the Robert J. Collier Trophy, In May of 1914, he delivered a lecture on the stability of airplanes at the Franklin Institute in Philadelphia. The Smithsonian reprinted that text. In 1913, Orville engaged the services of Grover Learning. He was the first graduate in America of an aeronautical engineering course, earning his Master of Arts degree at Columbia University, New York City in 1910. Having participated in the design and development of a glider flying boat as early as April 1909, and having made and flown a flying boat in 1912, he brought to the Wright Company a knowledge of seaplanes, very important for the further developments. This is the Wright brothers' aeroboat of 1913, the Type G. It had oars near the wingtips to aid in making turns on the narrow river. The hull was framed of ash and spruce covered with sheet metal, treated to prevent corrosion. The span was 38 feet and net weight 1,200 pounds. Its six-cylinder engine was located behind the pilot and passenger who sat side by side. In the next type of aeroboat, the horizontal elevator was raised high above the outriggers to avoid the spray. The engine was in the bow of the hull, the drive shaft extending aft between the seats to the double sprocket by which the chains to the propellers were driven. Here are Orville and Oscar Brindley, who was one of the most capable pilots in the Wright organization. Aeroboats were purchased and flown by a number of pilots, including Harry Atwood and Ernest Hall, who flew them principally on the rivers and lakes of Ohio. Type H resembled the F and was brought out in 1914. The span was 38 feet and weight 1,150 pounds. Its fuselage was of wood covered with canvas. It was rated to carry a useful load of 1,000 pounds and to have a speed of 56 miles per hour. A shorter winged version of the H was known as the HS. It had a somewhat better speed and rate of climb. Note that by 1915, the form of control had changed from the two-lever system to a wheel. This wheel could be turned to right or left so as to balance the airplane. It could be pushed for descent, pulled back to climb, and then on the side of the wheel, on the right side, was a sector that moved on the shaft, and that was moved up and down to activate the rudder. It was a very good control. In my opinion, it's the best of the 7 types of control that were produced during the history of the Wright brothers' experiments. Now, according to a letter written by Orville in 1943, there was no Type I produced by the Wright Company. But they had meanwhile licensed the Burgess Company in Massachusetts to make airplanes, and the Type I was the Burgess copy of the Wright Type B, used notably by Harry Atwood when he made his wonderful flight to the backyard of the White House back there in 1912. Another pilot of the Burgess type was my good friend Roy Waite, who barnstormed in the Middle Atlantic states. Other forms using the Wright type of wings were produced by Burgess, who also developed some original designs. This aeroboat, you will notice, has a long hull extending from the bow to the rudder. Previous types had the short hull with the outriggers. But this was identified as Type J. It was operated on the Hudson River, carrying passengers for hire. Note that it was equipped with hydrofoils beside the hull, both sides, to assist in takeoff. Now, Type K was developed for the Navy in 1915. It was a departure from conventional Wright designs. The propellers were in front of the wing, the lateral balance was effected by ailerons instead of by wing warping, and the rudder was rounded instead of rectangular. These cylindrical floats, originally supplied from the Wright factory, were unsatisfactory and were replaced by those designed by Captain Halden C. Richardson of the Navy and manufactured by Burgess. They improved takeoff and alighting. The K was the last Wright type to have the bent-end propellers, which had been used since 1908. The final design produced by the Wright Company was the L of 1915-16. It was a further departure from the original Wright types. It had a single propeller in front of a covered fuselage with a cockpit behind the wing. It had ailerons and wheel control. The speed range was 25 to 80 miles per hour and climb about 650 feet per minute. It was intended to meet military requirements for high-speed scouting, but as you see, it was very much below the performance of types then being used in the European War. That war had been raging for 2 years, and under the pressure of combat, a number of advanced designs had been developed. By the time the L was produced, Orville Wright's active direction of the original Wright Company became terminated. With the war in Europe intensifying, some American manufacturers received contracts for military supplies. The financiers and businessmen who had taken over operation of the Wright Company arranged a merger with a firm established by Glenn Martin. That's Martin there in the picture with Orville. The resultant organization being known as the Wright-Martin Aircraft Corporation. They were attending an air show there in 1917. One of the principal undertakings of the new corporation was to obtain rights to manufacture the French Hispano-Suiza engines, which were urgently needed for British and French fighter airplanes. They obtained the facilities of the former Simplex Automobile Company, which was up there in New Jersey. And not only did they make good copies of the French engine, but also they improved the manufacturing methods. Early in 1917, Orville served as consulting engineer to a new organization there in Dayton called the Dayton Airplane Company. They established a flying field for training on the outskirts of the city, and they developed a very good trainer, which was called the FS, because it flew successfully first shot. That was a really good ship. It had the Hispano engine of 150 horsepower there in the nose. With the entry of America into the war, April 6, 1917, the Dayton Wright Airplane Company was formed in that city, and Orville Wright became a director. Their first contract was for training planes, but following the decision of an official aircraft board that the British de Havilland IV airplane was the type that America should produce in quantity for combat service, the Dayton Wright Airplane Company received a contract to build 4,000 of them. An interior view shows the intensive production underway. And here we see a vast number of fuselages awaiting their wings before shipment overseas. These airplanes were powered with the Liberty engine, that dear thing I love so much, 400 horsepower, which was one of the major productions by America in World War I. Here is Orville Wright with the company's chief pilot, Howard Reinhardt, following a flight in the de Havilland IV. This airplane is now preserved by the National Air and Space Museum. A very significant and little-known development in World War I by America was the design and production of guided missiles, and in that project, Orville Wright had a vital part. Working with a group of engineers and manufacturers, including Boss Kettering, Virginius Clark, Harold Morehouse, and others, Orville participated prominently in the design of the wings, propeller, and other components. The Dayton Wright Messenger served as a manned airplane for testing the guided missiles. It had some qualities also as a private sport plane. It tested the De Palma engine. Sometimes these missiles were called aerial torpedoes, but the usual term was the bug. Successful test flights of the unmanned missiles were made, but the signing of the armistice on November 11, 1918 terminated the project. Post-war airplanes of the Dayton Wright Company include several modifications of the de Havillands, such as a company executive airplane and a similar one called the Honeymoon Express. With the closing of the war, the airplane industry became anxious to find ways to utilize its capabilities and resources. The James Gordon Bennett Trophy race had last been held in 1913, when it was won by France, but the war had suspended further contests. In 1920, the competition was reopened with France as the host, and America prepared 4 fast planes as entries. This one carried the hopes of the Dayton Wright Company. Orville Wright was much interested in it and apparently made wind tunnel studies of the design. I saw that model up at the Franklin Institute. This type was known as the RB-1, named for Reinhardt and Bowman of the Dayton Wright Company, who are here standing beside their entry. It was powered with a 6-cylinder, 250 horsepower Scott or Liberty engine. Its wing could be varied in airfoil curvature. The landing gear was retractable. The cockpit was enclosed. The estimated speed was above 200 miles per hour, but regrettably, in the race, it did not perform at its best. A broken rudder cable necessitated a forced landing, and the pilot, Howard Reinhardt, realized that it was out of the race. Sadie Lecoin, in a French Newport, won at an average speed of 168.5 miles per hour. Thus, with its third consecutive win, France kept the trophy. The last airplane to be designed by Orville Wright was named with his initials, the OW. It was a 3 or 4 place cabin plane, here shown during its construction with part of the wing uncovered. The engine was a Wright Hispano of 150 horsepower. Benny Whalen, who had learned to fly at the Wright School, was its principal pilot. I again thank him for these photographs as I show them to you. Although no longer engaged in the production of aircraft, Orville retained a keen interest in aviation. Here he is, soon after World War I, with America's ace of aces, Eddie Rickenbacker, and Major Rudolph Schroeder, renowned test pilot, who was affectionately called Shorty, being about 6'5". In 1921, Orville watched his sister Catherine christen one of Grover Loaning's air yachts, a type which won the Robert J. Collier Trophy for that year. In 1926, Orville was present with that same trophy was presented to Albert Reed for development of a metal propeller. At the left is Godfrey Cabot, then head of the National Aeronautic Association. General James Fauché was chief of the Army Air Service. Next to him, Orville is standing beside Mr. Reed. After the war, the Wright-Martin Aircraft Corporation had been reorganized, becoming the Wright Aeronautical Corporation. Some of their most successful engines were designed by Charles Lawrence. Thus, the name Wright was often linked with various airplanes, which used this corporation's engines. But Orville had nothing to do with their design. Here's the Wright Balanka airplane, which was such a sensation at the 1925 National Air Races where I photographed it. It was the forerunner of the Balanka transatlantic airplanes, which thrilled the sensation-loving public in the latter 1920s. Remember the Columbia. The Wright Whirlwind engine, which was an outstanding factor in the success of Charles Lindbergh's flight from New York to Paris, May 21, 1927, further perpetuated the name of Wright. Following Lindbergh's return to America and his receptions in Washington, New York, and St. Louis, his next wish was to pay his respects to the surviving brother of the two who first gave powered and controlled wings to mankind. The world record altitude flight of Apollo Suchek of our Navy on May 8, 1929, when he climbed to 39,140 feet, was in a Wright Apache airplane produced by the Wright Aeronautical Corporation, but powered with an engine made by Pratt & Whitney. A year later, Suchek set a new record of 43,166 feet with the same airplane. The Apache was one of the last types to carry the name Wright. Further examples of Orville Wright's continuing interest in aeronautical events and progress is his attendance at the International Aeronautic Conference that was held in 1928 in Washington. He is at the left. The group includes Henry Ford, Charles Lindbergh, Bill McCracken, A.P. Warner, and others. And here is Orville standing beside Porter Adams, who was president of the National Aeronautic Association. General Benny Falloy is there in the gray coat, chief of the Army Air Corps at that time. Now, during all this period, Orville Wright maintained his own laboratory in Dayton, conducting experiments in his wind tunnel, developing various mechanisms, constantly interested in learning more about the laws of aerodynamics. His final years were comfortable, with satisfying memories of worthwhile accomplishments. He had many friends, often inviting them to share his beautiful home, which he called Hawthorne Hill, in the residential part of Dayton. There, on January 26, 1948, he decided he should fix the doorbell. Perhaps he overexerted himself. That afternoon, he suffered a heart attack at his laboratory. After a few days in the hospital, he died the evening of January 30, 1948. He is buried in the family plot in Dayton beside his beloved brother, Wilbur. Wilbur and Orville Wright received many honors. One of the first was the gold medal from the Aero Club of France. The Royal Aeronautic Society of Great Britain gave them its gold medal. The Smithsonian Institution gave them the first Langley Medal. The gold medal of the Aero Club of America was presented at the White House by William Howard Taft. Congress voted them a gold medal which was given to them in Dayton. There are many memorials to the Wright brothers. The first was placed by the citizens of Kitty Hawk in front of the home of Captain Tate, where they assembled their first glider in 1900. At Le Mans, France, near where Wilbur made his astonishing flights in 1908, this monument was erected. And in southern France, where Wilbur continued his flying and instructed pupils in 1909, this monument was dedicated. The United States Navy named its first aircraft tender the USS Wright. At one time, her executive officer was DeWitt Clinton Ramsey. I had the privilege of knowing Admiral and Mrs. Ramsey. They established the Ramsey Fund for the National Air and Space Museum. The most famous memorial to the Wright brothers is their Wright Flyer of 1903. To the gratification of all mankind, it has been preserved. It is the most treasured exhibit in the National Air and Space Museum. Displayed as shown here in the place of highest honor, together with Lindbergh's Spirit of St. Louis, the X-15, which is the world's most advanced experimental airplane, and the spacecraft Friendship 7, in which John Glenn became the first American to orbit the Earth. The most impressive monument to the Wright brothers is at the top of Kill Devil Hill, about 4 miles south of Kitty Hawk, North Carolina. From the crest of this hill, they made their glides in 1901, 2, and 3, and from near its base, they made their first powered flights. The inscription around the base of this monument is particularly appropriate for us to recall as we come to the conclusion of our story of the Wright brothers. It is in commemoration of the conquest of the air by the brothers Wilbur and Orville Wright, conceived by genius and achieved by dauntless resolution and unconquerable faith. I want to wrap it up by emphasizing 5 points that characterize the Wright brothers' accomplishments. First, they prepared the scientific data necessary for the design of a successful airplane. Second, they built that airplane. Third, they taught themselves to fly it. Fourth, they advanced the development of the airplane through no less than 30 designs, as I've shown you. And fifth, they taught others to fly. Surely nowhere else in the history of invention has a basic idea conceived by 2 men been carried forward so far. The story of Wilbur and Orville Wright.